Hey Tanner, I'm making you this video so that you know how to do this. I gotta run. I'm not gonna have as much time today as I thought. All right, so this is the microprocessor. So it starts here with a counter that's just found. I think it's down here in is it wiring? A is it memory? Something. One of them. Yeah, there it is. Counter. It's just that one right there. The clock goes in right there, clear goes in right there, and de-increment goes right there. They're all labeled. If you just select this and highlight stuff, it'll show you exactly what to do, where to put stuff. So just go ahead and clear that. Clock, you just to step through stuff. Okay, and so now see here we have there's 8 bits that come out of it. The top, the least significant bits, 0 through 3, go down into the mux. 4 through 7 go into the decoder. The decoder is just another ROM here, which is found right there. It's just another ROM. You can go ahead and copy this here. Basically, what this is doing is that as you walk through. Basically, what this does is that it's as it receives the four bits from the the prom code, it'll select one of these, and each one of these corresponds with a set of pins from here. You should just copy this down here, and then you'll have it. That's kind of the hardest part of this whole thing. So then the top one goes to the register write enable. Next one goes to the register write address. The next one goes to display write enable. Next one goes to register source select. Next one is the accumulator. The next two, if you'll see here, this is actually 2 bits coming out here. So this is a 2-bit wire. The next two are the operation selector, and then there's the subtractor, which we'll get into in a little bit. Let's see here. We'll go next down to the mux. So it'll come down here. So the first bit, 4 through 7, the most significant bits, will go up here. So right now, this is selecting 1, 8, and so 1, 0, 0, 0, 1 is going into the decoder, and 8, that's I think it's just a bunch of 1s coming down to the mux. The source select is at 0, so the 8 is going through into the register. Now we're going to show you the register here. The register has the data in from the mux, and then it selects. Well, so first off, there's the write enable address. When it's at 0, it should be going to register 0. When it's at 1, it should be going into register 1, which is why we have the inverter and the AND here. Yes, okay, fine, whatever. All right. So see, like that. The write enable right there, and the clock right there, because you need clocks to work registers. You can take a screenshot of that and just copy that over. Here's what your 4-bit register should look like on the inside. It's the exact same as the lab we had a little while ago. Coming back out to the register here. So you'll see that both of them come out to 4 bits. Have 4-bit outputs. When they come out, we'll combine them back up, and then we'll drop the most significant bit. So it'll go 0 through 3 here, and 4 through 7 here, and then the most significant bit of register 1 will get dropped, and then go into reg out, and the register out will go into the display. Now let's see here. The register. This is the register 0 out. This is the register 1 out. And they both go into the ALU for the ALU inputs. So like on yours, let's see here. Yeah, so yours has the 4 like that, and then 4 like that. You're going to replace that with A's are going to be register 0, and B's are going to be replaced with register 1. And then the S0 and S1 are going to be replaced by your 2 source select, or not source select, operation select bits. So see, it comes out here to here, go in here. So let's see, we'll show the video ALU. All right. So as I said, the operation selector comes in here, and you had that set up the exact same. There's the adder, subtract, OR, and XOR. And then there's the register 1 input and register 0. And we'll get into the accumulator in a little bit, and then the muxes. All right, so the adder, I think you had yours set up a little funky Cole Medina, if I remember right. Oh, yeah. What you really had set up was that's weird. That's not quite right. So in your adder you should have this right here, and this is just in the textbook. So it's 3 AND gates and an XOR gate. The XOR going to sum, and the C out going, that's the carry out for the next bit. So then you see the carry out goes into the next one, and then the sum comes out here to your selector there. Okay, so these right here are for your subtractor. You should just go ahead and just copy this. Basically, if you remember when we did adding and subtracting, basically what we're doing is when you have this here. So let's say we'll go, yes, whatever. So we have 0, 1, 1, 1, and then we're gonna do subtract. And now what this is doing is these XOR gates are all going to turn that, they're going to invert it. So let's see, I'm not explaining this super well. Yeah, the XOR gates are going to invert the 2 numbers, and then the OR is going to add an extra 1 at the end of the number to turn this into a 2's complement of whatever number you're trying to put in. So it just works. Don't worry about it. Just copy this. The bitwise AND you had right. The bitwise OR you had right. The bitwise XOR you had right. Coming back out to main. Oh, right. The accumulator. So basically what you're going to do is, so you have all this coming out, and it comes into the accumulator, which is just another 4-bit register. The accumulator is just another 4-bit register, and you're going to have a clock and a write enable into it. The write enable being the accumulator. I should actually rename that. And then the accumulator goes out into the ALU right there. Okay. Let's see here. Clock goes in there, register out goes there, display, write enable, and clear all right there. So that's the basic form of this. The real tricky part is this bit right here. I'll show you a couple things about it, but I'm like, you kind of need to work through it on your own. But so this is an ACS2. So hang on, sorry, this right here, the display is an ACS2 display. Yeah, this one. It's an ACS2 display. And so the way that it works is that it receives, you see an ACS2 lookup table, and it receives, when it receives 2 bits, like let's see here, we'll show you H. So when it receives a 4, 8, most significant 4, least significant 8, it displays an H. And so so 1, 8, come over to our decoder. The number 1 selects the write enable for register 1. So write enable for register 1. So 1 8 puts an 8 in 1 8 puts an 8 in register 0. So we'll clock it. 2 4 puts a 4 in register 1, and so we'll clock it. 3 0 so remember 0 or 3 puts a 3 up in here and activates the decoder or the display write enable. 0 puts nothing in these, so what we're only getting display write enable, and so when we clock it, it displays the H. Again, 5 puts a 5 in register 0. 4 puts a 4 in register 1. 30 displays it. HELLO comma space BN. All right. Let's see here. So that's basically how that works. So when you're using your ALU, you're gonna put a number into register 0 and then a number into register 1, and then you'll select the bit that activates that does the add function. So you should always remember there's always information going into the ALU, but whether or not it's going through any operations and getting anything happening with it in the ALU, or rather the accumulator is something completely different entirely. And so I think it's 6-0 that you need for the ALU. But then you'll use the add function, and then once you do the add function, it's sitting in your accumulator, and so then you need to do the function that moves the accumulator into one of the registers. So that's when you do your source select, and then with one of them will have source select, write enable, and probably a 0 in the register write address, because you don't really want to put numbers in from the ALU into register 1. So you'll do register. You'll do the code for source select and to write enable to register 0. It'll put that there, and then you'll look at this here. Just a quick little cheat for you. All of the numbers in the ASC2 display have a 3 in front of them. 3 0 3 1 3 2 3 3. So it's pretty easy. Once you put your stuff from the ALU into register 0, move a 3 into register 1, and then display write enable, and it'll display that number onto the screen. Other than that, I don't know how much I can really show you without totally spoiling everything and making it like basically just cheating. But if you really need to, you can ask me and I can send you my video. But that's it, man. Good luck. Have a good one.